everyone, very good morning and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. So very good morning, how are you? Now, today we are going to discuss network theory PYQs, that is previous year question for ISRO Scientist SC exam 2023. That is for what? Electrical branch. Okay. And I am going to discuss some very important numericals from what? Circuit theory. And as you know, it is highly reliable subject. Means in competitive exams, you will be able to solve all the questions from circuit theory, or that is network. So very good morning everyone, Sheikh and Ashok. Now let me know that sound quality, picture quality, everything is fine. Yes, please. And what about your preparation? It's going well? Okay. Now you will get the idea about the previous year question in this session, right? How to solve the questions and which type of questions, right? Then this is a previous year question series. Give me 1 minute. Now that is my introduction. Myself Sanjay Rathi, and I am having 22 years of teaching experience in the field of competitive exams like ESE, GATE, ISRO, DRDO, BARC and other competitive exams. So according to my experience, first of all, try to solve previous year question so that you will get the idea what about the nature of the questions, and then solve some questions from previous year question paper of GATE exam, previous year question paper of engineering services exam. Now, this is my achievement. I have qualified and selected for engineering services exam AIR 16 in ESE 2005 and AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams. Sir, ISRO exam के लिए home center choose कर सकते हैं क्या? I think Meena, I will provide you the data for that in next session, or otherwise our team will provide you the data for that. Okay, is it possible or not? Okay then. And if you are preparing for GATE 2024, right, then this is free GATE workshop, 7 golden rules to secure single digit rank in GATE exam on 16th May, means tomorrow at 7:30 p.m. Please note the time. And that is by Abhinav Negi sir, highly experienced faculty, MTech from IIT Delhi, 10 years of teaching experience. You will get the idea how to crack the GATE exam, and that is the right time to start your preparation for GATE 2024, guys. Please join this workshop. You can register now for this. Then now watch this. Everyone use your calculator, copy pen, and please try to solve this question. For a circuit shown below, calculate the value of I1. For a circuit shown below, calculate the value of I1. What is the current through this branch? What is the current through this branch? Okay, you have to solve this, right? So everyone try to solve this question. The first answer is 43 divided by 160 milliampere. Then second answer is 117 divided by 32, 117 divided by 22 and 117 divided by 11 milliampere, because the resistors are given in kilo ohm. 1 kilo ohm, 10 kilo ohm, 10 kilo ohm, and what will be the current through this battery? That is the 0.7 volt battery. This is the 10 I1. This is the current controlled current source, and 20 volt battery is connected here. 10 volt battery is connected here. Okay. Now, how to solve this question? Then, watch this diagram. These are the answer. Try to give me the answer whether it is A, B, C or what? D. This is C. This is C option. Okay. Then watch this one. This portion is 10 kilo ohm, 10 kilo ohm, right? Then what we can do? Simply cut here. Okay. Now at this point you can apply the Thevenin's theorem, right? Like this point is what? B or A. This 10 kilo ohm, 10 kilo ohm and 10 volt. So what is the voltage across this point? This is the point A, that is the ground. 10 volt, 10 kilo ohm, 10 kilo ohm. Quickly you can apply the Thevenin's, so you can find a VTH at this point. VTH will become 10 divided by 10 plus 10 into 10. Directly you can say 5 volt. And what is the RTH across this? The 10 kilo ohm and 10 kilo ohm resistors are in parallel. Then it will become 5 kilo ohm. Okay, can you find quickly? Okay, 5 volt. So this is the answer, 10 kilo and 5 volt. Now replace this circuit. You can connect Thevenin's here. Five kilo ohm resistor, 5 volt battery. Now this A point is connected here. Now it will become very easy for you. What is the connection? Battery 0.7 volt, and this is the current I1. Now at this node, no need to apply anything. Simple. When we are having current source and a battery in series, then effective is current source. Effective is what? Current source. We are having the battery 20 volt, and that is what? Effective is what? 10 I1. Okay. Then 1 kilo. Now this is I1. This is, try to understand, this is I1, this is the 10 I1, and therefore when we are applying the KCL at this point directly on the diagram, incoming I1, incoming 10 I1, so what is the current here? 11 I1. Okay. Now finally you can apply KVL from this point to this point. When we are applying the KVL, it will become minus 5 plus 5 times of I1 plus 0.7 plus 11 times of I1 is equal to 0. 11 times of I1 into 1 and 5 times of I1. So 11 plus 5, 16 times of I1 is equal to 5 minus 0.7. That is nothing but 4.3. Now you can write the I1 is equal to 4.3 divided by 16, or you can write 43 divided by 160 milliampere. 43 divided by 160 milliampere. Which answer is correct? 43 divided by 160 milliampere. A is the correct answer for this question. So that is the use of what? That is the use of Thevenin's. So that will make the question easy. Or it is a no need to redraw the diagram and so on. Directly you can say this is the 10 volt. So what is the voltage at this point? 5 volt. And what is the resistance? 10 parallel with 10, 5 kilo ohm. Directly you can apply here. This is the 5 kilo ohm. This is the 5 volt. Now after observing, and this is the diagram. This is the plus, this is the minus 0.7, and finally 10 I1, 1 I1, you can directly say 11 I1. Or here it is the I1. So within 1 minute you will be able to solve this type of questions. Okay. So they are simply changing the diagram. Okay. They are changing the connections and so on. Now next question. So I think you are all are comfortable with this. So guys, please share the link of this session, and if you are new to this channel, then subscribe our channel. Okay, बहुत सारे सेशन आने वाले हैं ऑन ऑल कॉम्पिटिटिव एग्जाम्स, और आपकी जर्नी बड़ी स्मूथ होने वाली है, एंजॉय करने वाले हो ताकि आप इन सभी एग्जाम्स को क्रैक कर सको. राइट. तो दीक्षा जायसवाल एंड वेरी गुड मॉर्निंग एवरीवन. नाउ नेक्स्ट वन. Calculate V1 for the circuit given below. V1 for the circuit shown below. V1, what is V1? V1 is the voltage across the 3 ohm resistor. This is the answer. It is, sorry for that printing mistake. It is in volt, all in volt. All in volt. Okay. V1. 3 ohm, 5 ohm, 2 ohm, 4 V1, V1. This is the voltage control voltage source, and this is what? This is a current source, but depends upon the voltage. So we are saying that voltage controlled current source. Okay. Now this is a 2 ampere, 2 ohm, 5 ohm, 4 V1, V1 and 3 ohm. Now we have to find the V1. You have to find the V1. Then आप भी ट्राई कीजिए क्वेश्चन का आंसर क्या होगा. ये रहा आपके, दैट इज द डायग्राम. नाउ sir, for the mock test for ISRO exam, which app is best? Okay, so mock tests are available on BYJU'S app. You can watch, right, and you can give the mock test, right? Go through the, just all the tests are available. Choose what subject wise test, then what full length test, and I will give you the information about the links and so on. Okay, then try to understand. If this type of question na, so directly watch. If suppose I am using the mesh analysis, so what is the current in this mesh in the direction of 2 ampere I1? Directly you will get the I1 is equal to 2 ampere. Now in this direction, like I2, in the direction of this current, it will become I2 will become V1. I2 will become V1. Now you can choose I3. I3 in this loop. So what is the V1 is equal to 3 times of I1. V1 is equal to 3 times of I3, sorry. So what is the I3? 3 times of I3. So what is the I3? V1 upon 3. You have the equation number 1, equation number 2, equation number 3. Now, apply the KVL in this loop. Directly apply the KVL in this loop. Only. When we are applying the KVL in this loop, you can find the value of V1 directly. What is the V1 then? Now, 3, this is already we have solved. So this is the V1. So directly you can write, already we have solved the I3 in terms of V1 by 3. So no need to write the 3 times of I3. Directly you can write the V1 plus. Now, what is the current in this direction? I3. What is the current in the same direction? So, what is the current in this branch? I3 plus I2. So, you can write 5 times of I3 plus I2. I3 plus I2. Now, watch this current. This I3 in this direction, I1 in opposite direction. So, what is the current in this direction? I3 minus I1. I3 minus I1 in this branch. And what is the I1? I1 is 2 ampere. Already we have solved. I1 is 2 ampere. So what is the current in this direction? I3 minus 2. So when I3 minus 2, so you can write 2 times of I3 minus 2. That is equal to what? 0. So this is the V1. This is the 5 times of I3 plus I2. This is what? 2 times of I3 minus 2. Now, what is the I2 here? I2 is nothing but V1. And what is the I3 here? I3 is nothing but V1 by 3. You can write 5 times of V1 by 3 plus V1 plus 2 times of what is the I3? I3 is V1 by 3 minus 4 is equal to 0. Now everything in terms of what V1, now you can solve the V1. So that will become, you can take 3 as a LCM. Now it will become 3V1 plus 5 multiplied. This is the V1 plus 3 times of V1 plus 2 times of V1 is equal to what? 4. Then this is 12. 3 of 20 plus 2, 25. Check my calculation. 12. What is the V1 is equal to 12 by 25 volt. 12 by 25 volt. This is the 12 by 25 volt. So mesh analysis. Here we are using simple mesh analysis. It will become very easy question. Number of dependent sources are here, 4V1 and V1. So directly you can apply, and in one step you can solve the question. If you want to use any other method, it's up to you. If you are comfortable with any other method, then go with your method, because in network we can solve the question with different methods, right? Are you getting my point, everyone? बहुत सारे हो सकते हैं. कई बोलेंगे सर मैं KCL लगाना चाहता हूँ, KCL लगाइए. कोई बोलेगा कुछ और मैं सॉल्व करता हूँ. ओके, बट यहाँ पर जब लूप है ना, तो सीधा सीधा हम मैश एनालिसिस लगाकर 2 इक्वेशन निकालकर इसको सॉल्व कर सकते हैं. ओके देन, so this is the answer. Now, तो क्या कहना है? What about the nature of the question up to this point? Easy, right? Now, question on transient. For the circuit diagram shown below, calculate the voltage across the capacitor Vt at t equal to 160 microsecond. Now, when it is written, what about the arrow? This is the arrow. Nothing is given in the question. Normally, this type of question. So, exactly at t equal to 0, the switch will move from this position to this position. Suppose this is the position B, this is the position A. The switch will move from position B to position A. And when at the t equal to 0, the switch will move from position this to this. That is the information from the diagram. It is not written, but you can find the information. When the switch move from this position to this position, means for t less than 0, circuit is in what? Steady state. The circuit is in steady state exactly at t equal to 0. Are you comfortable with the transient, everyone? Now try to understand. This is the circuit. Exactly at t equal to 0, switch will move from position A to position B. So t equal to 0 negative, the switch is at position A. And this is the DC source. Circuit is in steady state. Steady state. Therefore, capacitor act as open circuit. For DC, it will act as open circuit under steady state. When this capacitor will act as open circuit, then you can find the initial voltage across the capacitor. Initial voltage across the capacitor VC. This VC0 negative will become 50 volt. This will become 50 volt. Now, what is the nature of capacitor? Capacitor does not allow sudden change of voltage. If the capacitor does not allow sudden change of voltage, it will become VC0 plus. Now, this is the voltage across the capacitor. When the switch moves from this position to this position, it will become source free RC circuit. What is this? Source free RC circuit. This is plus, this is minus, this is VC, this is R, and this is C. Now the current will flow in this direction and the capacitor will discharge. Capacitor will discharge. So what is the final value? 0. Because finally there is no source, that's why final value is 0. And what is the initial voltage across the capacitor? 50 volt. And what is the time constant of this circuit? RC. R and C. So what is the value of the R? 80 ohm and 2 microfarad. 80 into 2 microfarad, it will become 160 microsecond. That is the time constant. 160 microsecond. Then, if it is a source free response, no need to use the formula, but if you want, then you can use. What is the formula? VC is equal to V final minus V final minus V initial e raised to power minus t by tau. V final for source free response is 0, this is 0, this is 50 e raised to power minus t by r t, and it will become 50 times of e raised to power minus t by 160 microsecond. This is in microsecond, remember that. So that is the equation. Now what is asked here? What is asked here? What is the value at 160 microsecond? Means exactly at one time constant. When it is asked what is the value exactly at one time constant, then it will become very easy. Yes. Now, one time constant for source free response, always remember this diagram. Because calculators are not allowed, then you have to solve. This is the value. What is the initial voltage? 50 volt. Exponentially decreasing function, and in one time constant, it will reduce up to what? 0.368 of initial value. Okay, then you can multiply it and you can find the value. Okay, so what is the value exactly at 160 microsecond? it will become 50 e raised to power minus 1, that is the 50 by e, and you will find the value. What is the 1 by e? 0.368 of v. 0.368 of v. You can find the value 0.368 of v when we will solve. This is the answer, 18.4. 18.4. Okay, easy. That is the question. तो देख रहे हैं आप क्वेश्चन का नेचर देखो, very simple one, source free RC circuit. So you are familiar with that. Directly without solving anything you can give the answer. Initially it is connected here, capacitor acts as open circuit. What is the voltage across the capacitor? 50 volt. Okay, directly you can solve 50 volt. Now the capacitor is connected here, the switch is connected here, so this will become source free. So what is the time constant? Check the time constant, 80 into 2, directly you can write 160 microsecond. And what is the time constant? Given 160 means it in one time constant. In one time constant, directly you can write the 50 upon e or e raised to power minus 1. That is nothing but 0.368 times of 50. Directly solve it and you will get the answer. So this type of questions means what? Maximum 60 seconds. Maximum 60 seconds. We can solve it. Now, next one. Now, this is the question. Everyone try to solve this. In the circuit shown below, this is the circuit. Steady state was reached when the switch S was open. Steady state with the switch S open. So exactly at t equal to 0 negative, switch was open. Circuit in steady state with the switch open. Open. Now the switch was closed at t equal to 0. Switch को close कर दीजिए exactly at t equal to 0. The initial value of the current through the capacitor 2C. What is the value of the current through the capacitor 2C? I0. Initial value of the current means I0. Exactly after closing the switch, what is the current through the 2C capacitor? Okay, that is the question. First of all, try to understand what is the question, what is asked in the question. Now, how we can solve it? First of all, exactly at t equal to 0 negative, switch was open and circuit reached to what? Steady state. This is the DC voltage it is given. So for DC, inductor acts as short circuit under steady state. Capacitor acts as open circuit under steady state. Open circuit under steady state. Then okay, when capacitor acts as open circuit, what about the diagram then? This is a 18 volt battery, 2 ohm resistor. Inductor will act as short circuit. Capacitor, and now this is C, this is 2C, switch is open. This is the 2 ohm resistor, this is the 4 ohm resistor, and this is the 18 volt. Okay. Now, this both the capacitor will act as open circuit. What is the meaning of the open circuit? Means there is no current under steady state. This is the diagram exactly at t equal to 0 negative. There will be no current. Open circuit means. Now there will be the IL, and remember, inductor does not allow sudden change of current. Now 18 divided by 4, that is the value of the current. I0 negative is equal to I0 positive is equal to 18 divided by 4 plus 2, that is 3 ampere. Okay. Now what is the drop here? V. V is given by 4 into IL, 3 into 4, that is a 12 volt. 12 volt. So what is the voltage across this? Let this is the V1 and let the voltage across this capacitor is V2. If it is asked, then you can find the what is the voltage across the capacitor V1 and what is the voltage across the capacitor V2. So V1 will become, according to voltage division rule, 12 divided by 2C plus C. If you want to find the voltage across the capacitor 2C, it should be multiplied by the C. That will become 4 volt. And what is the voltage across the capacitor V2? Directly you can find 12 minus 4, 8, or otherwise you can apply the voltage division rule. 2C plus C up into what? 2C. You will get 8 volt. You will get 8 volt. So voltage across this capacitor is 4 volt. Initial voltage, and voltage across this capacitor is 8 volt. So what will be the question? Next question. This is what is the initial voltage across this capacitor, 4 volt. What is the initial voltage across this capacitor, 8 volt. What is the current through the inductor, 3 ampere. Right? Now, remember, capacitor does not allow sudden change of voltage, and inductor does not allow sudden change of current. Okay, now the switch is open. This time the switch is open. Now the switch will be closed. Exactly at 0 plus, close the switch. When we are just close the switch, 18 volt, 2, 4, and this inductor is converted into a current source. And what is the value of the current source? That is given 3 ampere. Because just I am writing the diagram exactly at t equal to 0 plus, it does not allow sudden change of current, the 3 ampere current. Now, it will allow, but what is the value? Voltage. Voltage is fixed. What is the voltage? 4 volt. And what is the voltage? 8 volt. And now this switch is closed. Now this switch is closed to 4, 18. Now it is a very simple, what is asked here? Very simple question. What is asked here? What is the current through this capacitor? Because it is a 2C. It means it is asked, IC. This is asked. Now this 4 volt is fixed, 8 volt is fixed, that is ground. 4 plus 8, what is the voltage at this point? Fixed, 12 volt. Now if it is the 12 volt, it is fixed. What is the current here? I. Current I is given by 18 by 2. 18 minus 12 by 2. 18 minus 12 by 2, that is nothing but 3 ampere. This current is 3 ampere. Now what is the current through the 4 ohm resistor? Because the voltage is fixed at this point, 4 volt. That is the voltage, this is the 4 volt, the parallel. This is the parallel connection. Watch this. 4 volt, this is parallelly 4 volt. So 4 divided by 4, what is the current here? 1 ampere. Current through the 4 ohm resistor is 1 ampere. This is the 3 ampere incoming, outgoing is 1 ampere. So what will be the current in this branch? 2 ampere, 3 minus 1. IC will become 3 minus 1, that is the 2 ampere. IC will become 3 minus 1, that is the 2 ampere. Now tell me, to find the current through this capacitor, current through the inductor is required. No, current through inductor is not required, guys. Very simple. 4 volt. If you have the idea, 4 volt, 8 volt. This 8 volt is required. No, 8 volt is also not required. So when during exam, when we are finding the 8 volt, when we are finding the current through the inductor, these all are redundant. We have to focus that simply we have to find the current through this capacitor. So what is the voltage at this point? The capacitor does not allow sudden change. No need to voltage divide, because once we will get the voltage, complete voltage across this V, that is what 12 volt. If this will not allow, this will not allow, the voltage at this point will remain fixed. Once the switch is closed, we have the voltage across this. Simply you have to find the voltage across the 2C. So in this way we can avoid unnecessary calculation. Otherwise this is the complete answer for this particular question. Then next one. What is the answer for this question? 2 ampere. I think no doubt it is clear. Again, by transient means it is not a very highly conceptual and so on. This type of not question, it is a normal question. Same type of diagram that is given in what one standard textbook, that is called what? Van Valkenburg. So if you want to practice some more question on circuit theory, you can solve some questions from Van Valkenburg. That is the textbook, and very conceptual questions given on what? Transient, right? Then okay, Now that is on what power, reactive and so on. Vs is equal to 200 cos omega t, it is given. This is the voltage source, it is given. Delivers power to a load at power factor 0.8 lagging. Means it is an inductive circuit. 0.8. This is the power factor. As you know, what is the power factor? Cos theta. That is equal to 0.8. Okay. The reactive power is 300 volt ampere reactive. As you know, the reactive power is Vrms, Irms. This is nothing but apparent power into sin theta. Into what? Sin theta. So this is the Vrms, Irms, sin theta. The active power is given by. Now, active power. Everyone try to solve this question. Active power. What is the active power then? Active means effective power. That is nothing but Vrms, Irms, cos theta. Vrms, Irms, cos theta. P active. Reactive power is given. This is given. No need to find. You can divide it. If you have the value of the theta directly, you can find the value here. Okay. This is a very simple question, guys. Okay. Tell me what is the answer. What is the answer for this particular question? Yes, please. Or some students want to get the sin theta. Then remember, sin theta is nothing but root over 1 minus cos square theta. Root over 1 minus, this is what, 0.8 square. 1 minus 0.64. Root over 0.36. That is nothing but 0.6. These are the standard values, guys. These are the standard values. So I am giving you the value for new students. Otherwise, students are familiar with this. If the cos theta is 0.8, then it will become 0.6. Okay. And then you have the value of sin theta. You have the value of the cos theta. So what is the P active upon P reactive? Directly you can write P active divided by P reactive. Vrms cancel out, cos theta upon sin theta. What is the value? 0.8 divided by 0.6. That is nothing but 8 by 6, 4 by 3. 4 by 3 times. So what is the P active? 4 by 3 times of P reactive. It will become what? 400 watt. It will become 400 watt because 300 watt is volt ampere reactive is given. 4 by 3 times of that. 1 minute. Or if you are familiar, directly you can use this formula, na? 4 by 3 400 watt. So with this question, what I want to say, power triangle. Get the idea about the power triangle. Leading, lagging, whether it is a leading circuit, whether it is a lagging circuit. Normal RL circuit is what? Lagging circuit. This is the RL circuit actually. RC circuit is what? Leading circuit. Current will lead the voltage. In RL circuit, current will lag the voltage. To get the idea about that, means there will be the question on what? Very, this is a very basic question. And power triangle and exact formula for that. Please, what about the complex power? P plus JQ. So what is the P and what is the Q? That is the P is what? Active power. Q is what? Reactive power. S is what? That is called what? Complex power. We can find like that. That is equivalent to magnitude of S is equivalent to what? Apparent power. Now, an ideal constant current source is connected in a series. So read this point and draw the diagram. An ideal constant current source is connected with an ideal constant voltage source in a series. Considering both together, the combination will give. Okay, very basic conceptual questions. What is the answer here? Sir, what is the relation between the PQR in series RL and parallel RL circuit? Okay, Prakhar. Now tell me, an ideal constant current source is connected in series with an ideal constant voltage source. Considering both together, the combination will be. क्या होगा बताओ भाई? Everyone. Power source? No. If IS and VS are connected in series, always remember that is what? Constant current source. Constant what? Current source. Prakhar, your answer is correct. Constant current source means, for example, try to understand. This is a 5-volt battery is connected here. And at the same time, I am connecting the 3 ampere current source here. Think like that. Everyone tell me what will be the current. It is a 5 volt or 10 volt or 20 volt. It doesn't matter. What will be the current in this branch? 3 ampere. If suppose I am connecting any network here, what will be the current enter into the network? The current enter into the network will remain 3 ampere irrespective of value of this battery. Okay, so that is the case, guys. Okay, this point is clear to you? Yes. Now, so this is a very simple. And similarly, when a voltage source is connected parallel with what? A current source. Now, what about the voltage? 10 volt connected in parallel. This is 10 volt. The voltage across this point will remain 10 volt irrespective of the value of the current source. And that's why effectively it behaves like a current source. It's voltage source. This is a particular network. 10 volt, 10 volt. The effective voltage at this point is what? 10 volt. The voltage source connected in a parallel with the current source. Effective is what? Voltage source. Okay. Constant voltage source. Okay. You have given the right answer for that. Okay. I will discuss Prakhar. 1 minute. Hai na? One questions again we will solve and then. Okay. Try to solve this question. यार ये तो मतलब आपके लिए है. That is a series connection and parallel connection of the capacitor. Series and parallel connection of the capacitor. 2F, 12F and 2F. These 3 capacitors are connected in series. Then this is in parallel. Then this is in series. Then it is in parallel. And finally you can find the C equivalent. But remember one thing. When the capacitors are connected in what? Series. In a hurry we can make the silly mistake. Then this what? That possibility of silly mistakes. When the capacitors are connected in series, it is not like a register. Then you have to write 1 by C equivalent. If there are 3 capacitors, so 1 by C equivalent is 1 by 2 plus 1 by 2 plus 1 by 12. That is the value. Right? This will become 12. And this is 6 plus 6 plus 1. 13 by 12. Or what is the C equivalent? 12 by 13. Up to this point. And then 8 and 5. When you want to find the 8 and 5, remember 8 and 5, these are also in series. So what is the 8 into 5? 8 plus 5 directly. Series. 40 by 13. Now this 40 by 13 and 12 by 13 are in parallel. When that 40 by 13 and 12 by 13 in parallel, so what is in parallel? Up to this point you can find 12 by 13 plus 40 by 13. This will become 52 by 13. 52 by 13 is what? 4 farad. So up to this point you will get the 4 farad. 4 farad. This is the equivalent. Now 4 farad and 1 farad in our what? Series. Are you getting my point, everyone? So what is the value? What is the value? Now redraw the diagram. Just I am giving you the simple calculation. This is 4. This is 4. And this is 1 farad. 4 series with 4, it will become 2. 2 series with 1, it will become 2 by 3. Now 2 by 3 and 5 are in parallel. 2 by 3 plus 5, it will become 17 by 3. 17 by 3. Now the 7 farad. Finally the 7 farad and 17 by 3, that is in what? Series. What will become 7 into 17 by 3 upon 7 plus 17 by 3. Then 3 cancel. Divided by 38. This is the 119 by 38. Which answer is correct? B. So very simple. So what is the chance we make what silly mistakes? Which type of silly mistakes normally? Again we are familiar with the register. So normally what we are doing, 2F, 12F, 2F. Okay, 2, 1 farad, 1 and 12, that is in series. So directly you can write what? 12 into 1 divided by what? 12 plus 1. 12 by 13. But the student can make the mistake here. 8 plus 5 is what? 13. Again, just like a register, you can add it. But be careful. These are again in series. So what is the equivalent? 8 into 5, 40 by 13. Now in parallel, you can add 52, that directly you can up to this point. This is the 4 farad. Now 4 and 4 in what? Series 2, 2 in 1, 2 by 3. Up to this point 2 by 3, then 5, 17 by 3, then 17 by 3, and directly without reduction, you can directly give the answer for this. This is in series. This is not in parallel. This is in series. Be careful about that. No need to redraw the diagram again and again. Okay. So reciprocal. Yes. Manoj, now it is clear? Everyone? Okay then. Now, just I am giving you the hint about that. Of voltage across 2 Henry inductor is 6 cos of 5t. 6 cos of 5t. Okay. Voltage across any inductor is given as 6 cos of 5t. Initial current is not given. What is the initial current through it? It is not mentioned here. Right. I am giving. Just wait. Right. The voltage across the 2 Henry inductor is a 6 cos 5t. Determine the resulting inductor current at t equal to pi if the inductor current at t minus pi by 2. So just I am giving you the hint. That is the voltage across the inductor 6 cos of 5t. No idea about the initial current. The value, two values is given at t equal to minus pi by 2. What is the current here? 1 ampere. Current is given as 1 ampere. Okay, no problem. And then second important thing, you have to determine the current at t equal to pi. Okay. Now what is the current through the inductor? I is given by 1 by L integral of I v dt. We are integrating from 0 to t plus what? Initial voltage across the inductor, initial current through the inductor. That is the equation when we are integrating from this point. This is the case. Now use this point, use this values. Okay, if you have the value of the initial current, but initial current it is not given. First of all integrate it and then use the formula, guys. Okay. Once you will get the initial current, what is the integration of 6 cos 5t? You can find the value, that is what 6 by 5 sine of 5t. Put the value of Henry, 2 Henry here, right? And then it will become 1 by 10 and then you can find. Then put the value of t here. What is the value of the t? Minus pi by 2 and equate it to what? 1 ampere. And you will find the initial value of the current, and then guys, once you will find the initial value of the current, then find at equal to t equal to what? Pi. Now, but the time is what? Negative. But the time is what? negative. Remember that point. Okay. So when we are finding the integration, so you have to use the negative value of the t. According to that you have to find the answer for this question. Try to solve this question. That is the assignment from my side. It is a easy question, but it is a conceptual question, and I am giving you the answer. That answer is what? A. I have given you the hint. Try to solve this one. Now, first of all, we will discuss that question, and then we will discuss what power and so on. Okay, tell me. Sandhya, you are getting A answer? Yes, I have given. Bilkul sahi. A. A is the answer for this particular question. A is the answer for this question. Determine the inductor voltage V in the circuit below for t greater than 0. What is the voltage across the inductor? तो क्या लग रहा है आप लोगों को from the previous year question? It is a very tough or moderate level. Yes, tell me. I can't say that is a easy one, but not so tough, right? From questions from the networks, questions on transient, questions on what basics of the network, so on. Tell me. Rahul, please try to solve that question. That was a very important one. Now you have to find the initial value, then you can apply. That answer is what? A. That's why I have given the assignment. Determine the inductor voltage V in the circuit shown below for t greater than 0. Now similar type of questions, exactly what is the mention here? Exactly at t equal to 0, switch will be open. Switch will be open. Means for t equal to 0 negative, switch was closed. When the switch was closed and circuit will be in under steady state. When circuit is in under steady state, now this is inductor. For t0 negative, switch closed. Switch closed means this is the case. 10 volt. Now 4 ohm, inductor will act as short circuit. This is the 10 volt. So what is the voltage at this point? 10 volt. This will act as short circuit. This is the 4. So what is the current through the inductor? Directly you can find IL0 negative is equal to IL0 positive is equal to 10 by 4. That is 2.5 ampere. If it is in ohm, that is the 2.5 ampere. Inductor does not allow sudden change of current. So it will remain 2.5 ampere. Now exactly at t equal to 0, switch was open. When the switch is open, we are just disconnecting the battery. When we are just disconnecting the battery, then remove this battery. Now what is this? Source free RL circuit. Source free RL circuit. For source free RL circuit, what is the time constant? L by R. What is the R equivalent? 4 plus 6, 10. L is what? 5. So 5 by 10. That is will become 1 by 2 seconds. This is the time constant of the circuit. For source free RL circuit, what is the final current? 0. Because there is no energy element. Finally, the inductor will discharge and current will become 0. What was the initial current? Already we have find 2.5 ampere. What is the formula? Final current minus initial current e raised to power minus t by tau. And remember, you can directly write I initial e raised to power minus t by tau. What is the tau? 1 by 2. 2.5 e raised to power minus 2t. Just I have given you the current, not the voltage, right? So what is asked here? You will write the 2.5, but what is asked here? Actually, determine the inductor voltage V in the circuit shown below. Inductor voltage is required, guys. If the inductor voltage is required, we have find the current here. This is not the voltage, this is the current. What is the current? Voltage, the voltage across the inductor? L di by dt. L di by dt. What is the value of the L? 5 into 2.5, that is the constant. Differentiation of e raised to power minus 2t. Minus 2, it will become minus 2 into my 5 into 2.5 e raised to power minus 2t. That is nothing but minus 25 e raised to power minus 2t. Minus 25 e raised to power minus 2t. That is the value. Which answer is correct? This one, D. So be careful about the question. Read question carefully. Determine the voltage, inductor voltage in the circuit given below. Right? Remember, capacitor does not allow sudden change of current, but it allows the sudden change of what? Voltage. Can allow the sudden change of voltage. And not it is initial voltage is not required. Initial voltage is not required. What is required here? Equation. What is required here? Equation. Okay. Now, second important thing, then directly we can solve it. Yes, no need to find the current. No need to find the current, guys. How? No need to find the current. This portion will act as open circuit. No need to find the equation of the current. Now, okay. Write down, this is the current. This current is fixed exactly at t equal to 0 plus. What is the current? 2.5. This will enter here. This will enter here. Write down the KVL. So it will become 2.5 into 6 plus 2.5 into 4 plus what V is equal to 0. So what is the initial value? 6 plus 4, 10 into 2.5. So what is the initial value? 25 volt. Once you will get the value of the 25 volt, got the initial value. It is a source free response. That's why the final value is 0. And you can directly use this formula. What is the Vt is equal to? V final minus V initial e raised to power minus t by tau. What is the tau? L by R equivalent. 5 divided by 4 plus 6, that is 1 by 2. Now use what is the final value? 0, 0. What is the initial value? Minus 25. Minus minus plus, and again it will become minus. It will become minus 25 e raised to power minus 2t. So tell me, in this case we are finding the equation for the current, or directly we are finding the voltage? Directly we are finding the voltage across the inductor. Find the initial voltage across the inductor. Directly you can use this formula. If you have idea about that, directly you can use this one. No need to write this, all this. Directly you can use. Okay. So that is about the question. Okay. Now, you go. Now, just I am giving you the hint about the RC circuit and RL circuit. This is the RC circuit. For example, this is the RL circuit. Okay. Then, when we are saying that S, this is called complex power. VRMS, IRMS, complex conjugate of this. And that is given by P plus what? JQ. P plus JQ. So that is the case. Now P on real axis and JQ on what? Imaginary axis. Then this is what P, and when I am saying that is the JQ. Okay. This is in which quadrant? First quadrant. And now you are finding the resultant here. And then you can find the angle here. And that is in first quadrant, remember. So for, it is a lagging circuit. It is what? Lagging circuit, guys. Here the Q is positive, P is positive. That is in first quadrant. That is what? Lagging circuit. It is an inductive circuit. So that is the relation. Then up when we are saying it is a reactive, P is what? Active power. So VRMS, IRMS, or what? Simply cos theta. When I am saying that is the magnitude of. what will become when we are resolving it? It will become as sine theta, cos theta. And what will be the q? Become mod of, if you want to find the q, then it will become what? Mod of s sine theta. Mod of s sine theta. Resolve it and you can find the value. Very simple. Okay. And then in case of capacitive circuit, the diagram RC, then it will become this is P, that is EP. Lagging. But if it is in a fourth quadrant, then it is a leading. Remember that. Because the capacitive circuit is what? Leading circuit. Okay, if you want, then we can arrange one session, complete session on that. Are you ready? This is a previous year question, time is over. But if you want, how many students want the session on that? Complete power, reactive power, effective power, active power, series RLC circuit, RC circuit, parallel RC circuit, parallel RL circuit, and so on. Right? You can develop yes, what is given that Diksha final plus initial minus, yes. Same positive sign when we are changing, we are writing like that. This is correct one. We have given the right one. Vt is equal to what? I am just writing V final minus V final. You can also write V final, V initial minus V final. That will remain same, e raised to power minus t by tau. That is also valid equation. Okay. So you want Manoj and Sikha Lakshmi? Yes. Then we will arrange one session for that. To please join and please like the session and subscribe our channel so that you will get the notification about that. Okay. Definitely we will arrange, and in one session within 1 hour you will get all idea about what that power factor and how to find the how to solve the questions, what is the P, what is the Q, and what is the S, apparent power, why it is in first quadrant, why it is in third quadrant, what is the RC circuit lagging and leading, each and everything we will discuss on that. I think you have enjoyed the session, everyone. Now I have given one assignment. Everyone try to solve that question and give me the answer in comments box, right? Otherwise, that after 2 days the answer will be available on my Telegram channel, that is Electronics by Sanjay Rathi. This is the assignment. Okay, try to solve this question. I have given you the answer, but try to get the answer. Okay, that is very important one. Then this is our result in GATE 2023, right? And try to give the best result. बहुत ही सिंपल, जितना आप सिंपल रखोगे अपने प्रिपरेशन को उतना ज़्यादा आपके चांसेस हैं एडमिशन और सिलेक्शन होने के। बहुत ज़्यादा कॉम्प्लिकेटेड मत कीजिए, बहुत ज़्यादा मतलब क्या होता है ना, जब एग्जाम आप देने जाते हो तो जितना तो एग्जाम में उसका डर उससे ज़्यादा बड़ा हो जाता है, इसलिए हम एग्जाम में अच्छे से परफॉर्म नहीं कर पाते। आराम से प्रैक्टिस कीजिए, मॉक टेस्ट दीजिए, क्वेश्चंस बनाते रहिए। अभी आपके सामने जो प्रीवियस ईयर क्वेश्चन सॉल्व कर रहे हैं उससे आपको कॉन्फिडेंस आएगा कि यस यार ये मुझसे बन सकता है, इसमें कोई भी ऐसी एक्स्ट्रा ऑर्डिनरी चीज़ें नहीं पूछी गई है। ट्रांजिएंट पे क्वेश्चन आया है, सोर्स फ्री आरसी सर्किट पे आ गया, सोर्स फ्री आरएल सर्किट पर क्वेश्चन आ गया, और आपने देखा होगा बहुत ही सिंपल वाला केसीएल केवीएल पे क्वेश्चन है। सब ये एक ही साल के पेपर का है, ओनली 1 ईयर पेपर ना, ओनली 1 ईयर पेपर, वैरायटी ऑफ क्वेश्चंस। Means what? First question on KVL, KCL. In one question we are applying the mesh analysis. In one question we are applying the Thevenin's concept. We are solving it. Fit 2 questions on what transient, 1 questions on what power factor, and so on. Okay then. Thank you very much for attending the session. You are on BYJU'S Exam Prep, the most comprehensive app for all competitive exams. Please like the session, share the link of this session, and subscribe our channel. Thank you.